All right, so now we're going to be dealing with multiplying polynomials. Now, when it comes to multiplying polynomials, there's a few different strategies. I'm kind of curious as to how Edmentum's going to handle it because it is a complex topic. So, my favorite way of multiplying polynomials, we've done it a few times, is using what's known as the box method. And what you do is you're going to end up multiplying it by each term. So let's say I had like a trinomial multiplied by a binomial. I would write it like this. Let's say these were my two terms. And then I would do what is x times x squared. I would write x cubed. This is the same thing as doing the distributive property, except in my opinion, it's a little more organized. It's kind of like you're solving a puzzle. So instead of going like, there, there, you have three things that you write down. Those three things that we would write from that would end up being right here. And then you would also have to distribute this, -3. So you would distribute it here, distribute it there, and you get another three things. So you would do that here. And then afterward, you can write this all in a nice straight line and organize it better. This requires a lot more picturing. This one, you just have to remember it's whatever's on the side times whatever on the top, and then you can combine things. And what's usually nice about this is, let's say I kept going and I went like, oh, this is, let me go back to my blue. This is 2x squared. This is x. This is -3x squared because it's -3 times x squared. This is -6x, and this ends up being -3. What's cool about this is your diagonals, as long as you write it in standard form and there's no like skipping, your diagonal should be able to add up together. Because see how this is an x squared, that's an x squared, this is an x, this is an x. As long as it's descending. So if you have something like x squared plus 1, you might, if you want to make it all nice, you can do it this way. Or you can just keep in mind, like, hey, I don't have an x term, so it's not going to be as nice as it usually is. That's one way of multiplying polynomials, but let's get into the discussion. All right, so multiplying polynomials. What is our objective? So our objective here is to model with mathematics what is to do polynomials. Understand polynomial forms analogous to integers. So this is just saying like, hey, it just keeps repeating the state standard, so it's not really giving us an objective. But we're supposed to understand that multiplying polynomials is going to help us um, understand that polynomials are all closed. So if I multiply a polynomial, I'm not going to get something else. All right, so let's get into this. So first thing is our warm up. So as always, let's identify these. So there is no power here. There's an x, there's a variable, but there's no power. That means it is a linear function. How many terms are there? Well, it's not being added to anything else. There's only one thing here. They're being multiplied, but they're not being added to anything. So it's one term. So I'm going to call it a monomial. So this right here is a linear monomial. This one, it doesn't have an x. So this is literally just a constant. And constants are always going to be monomials. There's kind of no other way around it. They're just constants. So you never call it a monomial constant. It's just we have to fill something out in here. This one has a squared. Squareds are quadratics because quad meaning square. And there's two of them. So this is a quadratic binomial. Usually they have them backwards, so I'm a little confused as to why it's not a binomial quadratic. This is a quadratic binomial. I guess they're interchangeable. You can do it in either order. Um, so again, there's a squared. So the highest power the degree is 2 because that's the highest power, so it's a quadratic. But this time there's 3 things being combined. So we're going to call it a trinomial. And the last one, we're looking at this, there's an x with no power. That means it's a linear function. And it's going to be a binomial because there's 2 terms. So it's important to note that the reason why this is linear is uh, there's nothing really changing with the x. It's at a constant rate of change. So a constant rate of change means that it's going to be a straight line. In real life, there's a few things that are constant rates. The biggest one they always do is the phone bill, or anytime you're paying for something. Every time you buy more, it increases at a constant rate. There's no price changes. If there's price changes, then the function just changes. So that's a good way of kind of thinking about linears. A lot of people are like, well, why? Well, who makes up these rules about uh, linear functions? It's like nobody makes them up. That's just how it works. If you were to graph it. All right, so we're going to be talking about the distributive property. So the distributive property, oh look, here they are showing this here. Uh, oh, so what we're doing here, Sheila broke up each number and used a box to help her multiply it into 2 parts. So you know what's hard is when you're multiplying double digits, right? It's really hard to multiply double digits. So what she's doing is like, instead of calling it 12, I'm going to call it 10 plus 2. Instead of calling it 16, I'm going to call it 16 plus 6. Because let's say I memorized all my ones tables all the way to my tens tables. This should be really easy for me to solve. And then what I'm going to do is I'm going to use the distributive property. I'm going to 10 times 10, then 10 times, let me use my pen. I don't know why I'm not doing it with my pen. 10 times 10, 10 times 6, and I'm going to do 2 times 10, 2 times 6. Well, that's kind of hard to see. So what we did here is this 10 times 10 is this box right here. This 10 times 6 is this box right here. There's a 2 times 10 that's going to be, oh, I'm sorry, I did this wrong. I didn't realize which way they were going. That was my bad. Oops, that was supposed to be blue. That 10 times 6 is this part right here. I didn't realize that they put the first thing on the top. That was my bad. They put the first one on the top. I'll keep that in mind. I always put my first on the left. They put it on the top. It doesn't matter. Your answer's still going to be the same. It's just how the boxes are arranged are differently. And then this 2 times 10 is this box right here. And finally, this 2 times 6 is going to be this box right here. And what we do after that is we're just going to add everything together. So this is kind of setting us up for using the box method later on. We can do this with numbers. We'll be able to do it with variables later on. So if I look at this, another way that they did it was they broke it up into, well, I can do 12. I know my 12s tables. 12 times 10 is 120. 12 times 6 is 72. All right, and let's say we don't trust any of that nonsense. Let's trust the calculator. I don't really trust calculators too much because sometimes they're just programmed weird. But for multiplication, we can definitely trust the calculator. That's easy to do. So we get 192. All right. So yeah, it works out. So let's start doing that with numbers, with integers and stuff. We're going to use the exact same property now. We're just going to be using it with variables and other things. So we've already discussed what a polynomial is worth, so that's why I'm not really talking about too much. So if you're multiplying a polynomial, the easiest way to do it is your smallest number of terms gets multiplied by your larger number of terms. So because this 3x has less than this trinomial right here, it's easy to do monomial times a trinomial. You have to distribute a lot less. So if we go here, you're distributing it. So what they didn't show was us distributing it. This is how they kind of show it, is by doing like, oh, we're going to do that 3x times all of this right here. And then we can just multiply those out. They're showing it visually. Not a big fan of that. But it works out because they're showing us the power. So if you forgot how to multiply powers, you just take the power of this plus the power of that, and that's your new power. So whenever you're multiplying with the same base, the same letter or variable, you just add the powers. And then you just add the regular numbers together. So they're showing us how to do that step by step. If you're having trouble multiplying, this is kind of a good way to organize it. It just kind of threw me off when I first saw it, like, oh, that's 3 times x. That's what 3x is. What's 3 times x squared? Oh, that's just 2 times x again. And then they rearrange it. And then this will be your answer because you're adding all of these together. Since they're positive, oh, this one was a negative. They didn't show that. So they didn't show the positive times the negative part right here. There we go. So definitely remember that positive times that negative. And then you combine them together. So this was a negative 12 because we had a negative 3. Oh, I see what they're doing. They brought the negative into play later. I guess that works. All right, so going into the next one. All right, so we want to distribute this. So what we're going to do here is we're going to do negative 5x squared times 6x minus negative 5x squared. I know that was a parentheses and it looks like a terrible x now, but I forgot it. I'm sorry. Times 1. Or another way to, well, that's fine. So notice how there's a negative 1. So I just made it a 1, but I put the negative over here. So this allows me to do negative 30. 5 times 6 is 30. X cubed, because 2 plus the invisible 1 on this x power. And then a negative times a negative is a positive. And then it's 5 times 1, which is just itself. So that's how we get our answer. That's how we got that. Put the answer key in there. That negative 30x cubed plus 5x squared. That's our answer right up here. I should have written it down. I'm sorry. And then you can see their explanation here. They're distributing it out. I personally like the box method, where I think it's just better aid. So if you do 5x squared, do a box, it's a 1 by 2 box because it's a monomial times a binomial. I think Edmentum just hasn't gone to it yet, but I think this is a good way to do it. So you get negative 30x squared. You have a negative times a negative, so you have a positive 5x squared. You just have to remember it's this times whatever's here. So there is a little bit of mental math there. All right, let's go to the next one. So Algebra Tiles. This is important because the activity for this unit is done using Algebra Tiles. So definitely click on this and it'll explain to you about Algebra Tiles. Keep in mind a unit of 1 is just obviously 1. How is the square of 1? Well, it's 1 times 1. An x tile is 1 times x. This is important for when we're manipulating them later on. I'll try to have a video that kind of explains how to do the unit activity. And hopefully it helps. So let's say we do algebra tiles. So if we have x plus 3, we have x plus 3 right here. And then we have this x minus 2, which is right here. And then we're going to fill in the tiles. Well, what's x times x? X squared. Well, what's x times 1? That's x. What's x times x? So what we're doing here is we're just multiplying this side times this side. And that gives us a 1 here and an x here, which is this tile right here. So that's all we're doing. This is also, and then we'll do the next step. So then we're going to do the -2. So this is a fancy way of doing my box method, which is, let me do my box method here. They're using algebra tiles instead of it. I actually really like the algebra tiles. It's a really interesting way of doing the box method. X times x minus 2, and then we have x plus 3. So here there's an x squared, because it's x times x. What's x times 3? 3x. So that's this box right here. That's our 3x. This is our x squared. Let me do that in a different color box. Do it in yellow. That's this box right here. And then we're going to do in here -2 times x. That's -2x, which is this right here. Here's our -2x. And then there's -2 times +3. That's going to give us -6. So that's this part over here. That's that -6. So, like I said, this is an interesting way of doing the box method. And then one of the interesting things is these two diagonals, this -2x and this 3x, or this -2x and these 3x, will combine to do a regular x. We'll see that right here in the next one. Let me just erase this. Cool. You see that these -x cancel out with a positive x, and the -x cancel out with positive x. So we're left with a 1 positive x. So our answer is going to be on the next slide. Our answer here becomes, oh, they didn't answer it for us, huh? Interesting. Oh, here it is. They answered it right here. 1x squared, 1x. So that's here. I really wish they would have shown the answer here more. And then -6 right here. There's 6 negative ones, which is -6. -1, -2, -3, -4, -5, -6. Another way of doing this is the FOIL method. So the FOIL method is known as first, outer, inner, last. So first is the first terms of each polynomial. So we have x times x. That's the first one in this parentheses. That's the first one in this parentheses. Next is outer. Outer are the what's outside. So this one's on the left outer side, and this one's on the right outer side. Then it's inner. So now we're distributing the 3. So FO refers to distributing the x. IL refers to distributing the 3. You're going to distribute that. All right. And then moving on. So let's do the FOIL method for these ones. So first we would distribute the first ones, 2x and 4x. It's 8x squared. Okay, that makes sense. Then we would distribute the outer. That's what's in red right here. We get -10x. They're separating everything by plus, and I actually don't mind this. It makes it nice and simpler to realize later on what we have to do. Instead of going like, well, was this a plus or is this a minus? Let's call it a plus for now, and we'll deal with it later. This one, it's a positive, so 3 times 4x when we're doing the inner. So it's a positive, so we're not going to put a double positive, so they don't worry about that. And then +3 times a -5 is -15. Now all we're going to do is simplify this. So positive and a negative is obviously a negative. So that's why they kind of bring them down. But also, so this becomes just a negative. This positive minus becomes just a negative. These two red ones we can combine because they're like terms. So we're just going to combine them. So a lot of you might have done FOIL in the past. So that's definitely something I'll refer to. Um, However, later on in later units, you're going to be factoring, and the doing that box method is going to be very, very useful. So I'm definitely going to refer to the box method a lot more. Right. What is the polynomial of these two binomials? All right, cool. So what we're going to do here is we're going to do this, do this, here, and here. And I'm going to do x squared minus 5x, 2x minus 1. You know what? Let me do it the way Edmentum does it. That way I don't confuse you guys. The first term should go on the top. It doesn't matter which way you do it. I'm just doing it the way Edmentum does it just to make this easier. First term goes on the top. Second term goes on the side. What's 2x times x squared? 2x cubed. So what I'm asking myself is, what's 2x times x squared? And I'm like, okay, that's just 2x cubed because there's an invisible 1 here. Then my next question is, well, what's 2x times negative 5? 5 times 2 is negative 10, and there's only one x, so negative 10x. Now I'm going to ask myself, what's negative 1 times x squared? That's going to be negative because it's a positive and a negative, or a positive here and a negative here, sorry. So I got x squared. So this is negative x squared. Next, I have negative 1 times negative 5. Well, this is a negative times a negative, so that's going to be a positive, and 1 times 5 is 5. So this is a positive 5. Then I can combine any like terms. So here's my like terms right here. So those like terms, what am I combining? I'm combining negative. Oh, I don't. Oh, actually, there are no like terms. Oh, perfect. So remember how I said that if you're missing a term, that'll happen? These are not like terms because if you look, this is an x squared, this is an x. So you can just write this all down. So I'm just going to write everything I got, and I'm going to just write it down. So I got 2x cubed minus x squared. I just look at the next power, which is a squared. Let me just fix that erase mark that I did here. Not the best fix of the erase mark, but there we go. And then we have minus 10x because of this part right here, and then a positive 5. So my answer ends up being 2x cubed minus x squared plus 5. Ooh, almost got that one wrong. And they showed me the answer at the beginning. So there we go. All right. So that's how I do it with the box method. And like I said, we'll be talking about factoring later, where they give you this and they want you to figure these out. So that'll be interesting. Um, but I want you to get used to doing the box method because it makes that a lot easier to learn. All right, so now we have an even bigger one. So this is going to be a really, really big box. So what we're going to do here is we're going to make this really big box. Separate this into 3 parts. Separate this into 3 parts. Oh, that middle one kind of got the short end of the stick there. So this is going to be, and you always want to do it in order. Oh, actually, I just saw something. This isn't as bad as I thought. Always look at your thing first, and I'll show you what I saw. You guys might have spotted already. This is an x term. This is an x term as well. This is an x, or oops. This is a constant, and this is also a constant. So you want to make sure you have your terms simplified, or your polynomial simplified. This polynomial is not simplified. I can rewrite it as 6x minus 2x minus 9. And then the other polynomial, I can rewrite it as 5x plus 8x, because it's a positive 8, minus 5. Now I have like terms here, and I have like terms here. That gives me 4x minus 9, and then I have 5x plus 3. So this box isn't as big as I thought because of this part right here. So I'm going to say 4x minus 9. So I'm going to put that little division up right there, and then write the rest of the box. Draw the rest of the box, and this becomes 5x, and this is a 3. So this becomes 20x squared. This is 12x. This here is negative 45x because it's 5 times negative 9, so that's a negative. And then this is going to be negative 27. Now we have to combine like terms. So in this one, these two do match up. This is an x term, this is an x term. This 12x is an x term, obviously, and the negative 45x. So what is negative 45x plus 12? The way I like to think about this is if they're different, you know you're subtracting. So if I grab my calculator, they're two different things. This is a positive, this is a negative. So because they're different, I know I'm subtracting. So 45 minus 12. What number was bigger? The negative was bigger. So this is negative 33x. That's an easier way to think about it, in my opinion. So when I write this down, I'm going to write 20x. I'm going to use the little exponent thing, or you can use control up. If you hover over it, it's like, hey, you can use control up. 2. And my x term is this negative 33x. And my constant is negative 27. And I can submit that. All right. And so this is, like I said, I like using the box method more than FOIL. One thing to make sure is make sure that your polynomials are simplified in simplest terms before you start making the box. You saw I was going to make a 3x3 box. That would have been, that would have taken a minute. All right. So here you can watch their video. Again, I really like watching their videos because they have the time to do the colors a lot better than I do because I'm doing this live and I don't want to um, take too much time doing the colors. So it is really good to watch their videos. They do it with distributive property. So I use the box method. Watch their video to get a better idea of how they do it with distributive property. Keep in mind, this might look like a nightmare, but keep in mind if I would have done it with the box method, it would have been a 3x2 box. So you would have all these little numbers right here. Just keep that in mind in case you're like, well, his box method was faster. It's like, oh, this one's my box method would have taken a while too. So we go back to her idea. So her idea was really interesting. She did a 2x2 box. I'm sorry. And then she added everything inside here. So that's how we end up getting our product. All right. And then we're going to do the same thing here, the same basic idea, except now we're not dealing with numbers. We're dealing with polynomials. So what they do is they always put the smaller thing on the side, which I think is weird because earlier they put the first thing goes on top, but now they're like, smaller thing on the side. Smaller thing on the side is better. It'll help you if you ever get into more specialized mathematics. I'm not going to say it's harder or higher level. It's just they use these things called matrices, and you want to get used to having the one with less terms on the side. All right, and then you fill in the box and you combine any like term. So usually, like I said, if there's no missing x's, it's your diagonals. And then that'll give you your answer. So I like this method. Like I said, this is the method I'm going to be teaching a lot of. All right, so let's go into the next one. Go to unanswered. So now we're going to do this product. So in order to do this, we're going to box method this, of course. X, let me do a darker color. I don't like that. X and positive 9. We're going to do our box method. It's 3 terms. And they're not missing a term. It goes 2, 1, 0. This is 1, 0, so that works. By term, I mean like a degree. I should mean an exponent. I shouldn't say term. They have all the degrees in here. And we're going to say 4x squared, 5x, and 6. So this is 4x cubed. Then it's 5x squared. Then it's 6x. Essentially what we did is I distributed the x. Also keep in mind, since the first is on the side, I knew where the boxes were. Last time they're like, oh, the first goes on the top. It's like, that doesn't work because it doesn't look like it's distributing. Never mind. I'm getting off on a tangent. So the next thing we're going to do is we're going to distribute the 9. So if I distribute the 9, I'm going to end up getting 36x squared. And then I'm going to do 45x. And then I end up getting 54 here. So now that I distributed those, I can combine any like terms. So I got lucky in that the diagonals work. This only works when it goes in descending order and they're not missing a power. All right, so this becomes 4x control up squared, or you can use this instead of control up. And then I'm going to combine these two. So 36 plus 5 is 41. Luckily, these are all positive, so it's all adding. So that's 41x. In case you guys are wondering how I do that so fast, what I do is 36 needs 4 to become 40. I take 4 from here, I'm left with 1. So the 36 became a 40, and this got bumped down to a 1. This 45 needs 5 to become 50. I'm going to take it from here, so this becomes a 1. So I have 51. And obviously, if there's not enough, then we don't have to worry about it. And then we do plus 54. All right, so this should be our answer. I think I added everything right. Let's find out. Incorrect. Oh, I already see what happened. This was supposed to be a cubed. Oh no. Uh, I'm going to make a mental note of this, and by mental note, so you guys can see that I'm actually making it out, I'm going to take a little snippet of it. All right, so this was our answer. Well, there's no point in me doing it because it's up here. So I guess I don't have to make a mental note or a snippet. I can just copy from there and not be dumb. All right, so let me retry this. 4x. I think we just haven't done trinomials yet. So I was like, oh, it's a squared. Plus 41x. Roll up squared. 51 plus 51x. I guess I did need that screenshot. I forgot that I had added these two together. And then 54. So there we go. 3, 2, 1, 0. Okay, cool. There we go. I just forgot my power. That stinks. I really wish they would keep your answer there. That way you could edit it. But instead, Edmentum has to reset it. All right, so moving on to the next thing. So here they're just showing us how they're distributing it. So they're doing the distributive property. They're always doing the one with the least to the most. It's the easiest way to do FOIL, is you want to go from the least amount of terms to the most amount of terms. It's just less numbers to keep track of if you do it that way. Otherwise, you would have to distribute 3 numbers. But in this case, you're only distributing 2 numbers. So let's see what we got here. All right, so if we look at this, again, I'm going to do this with the box method. I don't really want to do it with distributive property. You can, but this is distributive property. Like a lot of people are like, oh, I just want a FOIL. It's like, this is foiling. It is literally the same thing. We're doing this, this, and this right here and here and here. So let's write this out. And this is going to be 6x squared, 8x, and 5. So I get, I'm getting big numbers here. Keep in mind that there is no x term here. So because of that, we won't be able to add the diagonals. So this is 24x to the 4th, because 2 plus this 2 is 4. And then this is 12x squared. This is going to be 4 times 8. Well, 4 times 2 is 16. 2 times 16 is 32. X cubed, because there's a 1 here and a 2 here. Then we have 20x squared. Cool. And then we have 16x. And then we have 10. All right. So now what we're going to do here is we're going to add this one with this one. All right. So this is going to be, and nothing else adds up. These are the only things that add up, and they barely got there. Like if we didn't have this 5, we wouldn't have been able to combine them. So this is going to be 24. The 3, that's going to be a 32. The x squared, that's going to be 12 plus 20, so that's going to be 32. The x's is just a 16. And the constant is going to be 10. So let me clear this out. So that's a good way of kind of doing this. Use numeric. I don't know why it's telling you to use numbers instead of words. That'd be kind of weird for us. 20-4, like just writing it out would be a little strange, I think. And they're showing it by distributive property here if you want to see how they do it with distributive property. All right, combining operations. So, let's see what this is about here. All right, so combining operations. Oh, this is just the idea of using order of operations along with polynomials. The interesting thing about polynomials is it's kind of hard to do it because there's letters we don't know. Technically, like if we have this x plus 3 and this 2, we're supposed to do the parentheses first, but because we can't, that's where we have different properties like the distributive property come into place, because we're unable to do it because we don't know what x is yet. We want to keep doing math and figuring this stuff out without that number yet. So for example, like let's say it's like, well, I get paid, but I don't know how much I'm getting paid, but I know I have to pay $50 for my phone bill. Well, how much money will I have left after I pay my phone bill after 5 paychecks? You know, if I get paid the same amount every single time. But I don't know how much my checks are yet because I started a new job or this and that. This allows us to kind of figure stuff out a little bit. All right, so let's see how order of operations work with numbers. So we've done this before. You have to do parentheses first, then you're going to do multiplication, then you can finally do the subtraction, right? So that's how you would do it in order of operations. All right, the next one. So if we're doing this, we can't do this. So this is the same idea. If you look back, it's the same idea, parentheses and that. And this is the same idea, parentheses, this. So the way it works with numbers is you can't add those, so you have to distribute. So that's how we're doing this. First, we have to distribute to get rid of the parentheses. When we get to the double set of parentheses, that we have to use either FOIL, the box method, or distributing. It's all the same thing. Well, FOIL is just double distributing. The box method is a visual aid in how to distribute. So it's all the same thing. Finally, we add everything we got. So they put like terms in blue and red, and the constant doesn't have a like term, so that's why it's the only thing left in black. And all right, cool. I was like wondering, I was like, I thought I hit the next button. So now we're gonna have to do this. Ugh, and they gave us the answer. So the first thing we want to do is we want to do the multiplication. So we're gonna have to do this multiplication. So I'm gonna box this up, put it in a nice little box. X 5, x minus 7, x squared, 5x, negative 7x, negative 35. Here we have x squared minus 2x minus 35. Cool. So we have this going on right here. The next thing we're going to do is we're going to have to keep in mind, I still haven't dealt with this negative. We're going to distribute that negative, get rid of the parentheses for all of this. So we have 4x squared plus 8x plus 15 plus 2x squared minus x minus 27. And we're going to deal with this negative here. So I'm going to distribute that negative to there. So I end up getting negative x squared plus 2x plus 35. Now I want to do all of my terms. So I'm going to circle all my x squareds. And remember, I'm circling the sign as well. I didn't really do a good job on this one, but it's a positive, so we're good. Then I'm going to circle my next term. So 8 negative x and 2x. All right. So this one I get, so 4 plus 1 is 5, but then I'm also, so these two kind of cancel each other out. This negative x squared and this positive x squared. We get 4x squared. Then we're going to combine our green ones. So 2 take away the 1 is 1 plus 8. So that's going to be 9. So I'm going to do plus 9x. And then finally, I can get to, I guess I'll do it in purple, 15, negative 27, and 35. Oof. It's a lot to unpack here. I like doing my negatives at the end because it's easy to enter into a calculator. So let me clear this out. So 35 minus 27, 27 is that. Then we're going to add another 8. So we get 16. So this is going to end up being plus 16. So all of this complicated thing just summed down into this easy thing right here. I'm just going to click the answer key so you can see that it matched. I did something wrong. What did I do wrong? 35. Huh. Did I plug something in wrong? 35 take away 27 plus 15. Oh my gosh, plus 15. I was looking at the green instead of the purple. So that's what happened there. Oh my gosh. There we go. 15, not 8. Look at your colors. I recommend underlining and double checking your work just in case stuff like that happens. It happens to any of us, guys. All right, so going to the summary. So as always, using algebra tiles is very useful. It's a different way of using the box method. You can also do FOIL. So FOIL is just a way to kind of remember first, outer, inner, last. It's just how to remember the order in which to distribute. And then you can also use this box method to help you organize it a little bit better. So these are the methods in which to kind of remember it. If you need an algebra tile, you can always bookmark it onto your Chrome or Safari or what have you. That way, when you have a problem, you can open it up. All right, guys. Hopefully, this helps out. And I will see you guys next week. Oh, keep in mind, the videos are supposed to be every week. It might be delayed because I do put out videos for other math levels, but the way it'll always be is if you're subscribed to the YouTube channel, um, what it'll be is there'll be an algebra video, then a geometry video, then an algebra 2 video, then a pre-calculus video, and then back to algebra 1. So that's a good way to kind of get an idea of when the algebra videos are. If in case you're subscribed and you're like, where's the algebra videos? It goes in order depending on time that I have to film them. All right, guys. Hope you. Oh, and keep in mind, some of the higher levels don't get done in one video; they take a few. All right, guys. So I'll see you guys next week.